Hi everyone. So we are solving this part sum question today. It basically says that we'll be given a root of a binary tree, and we are also given an integer called target sum. We have to return true if the tree has a root to leaf path such that when we add the values of all the nodes along that path, they actually equal the target sum. And in here, in this tree, we have this 5, 4, 11, 2 path, which adds up to the target sum, which is 22. So we have to check if there's such a path, we have to return true. If there's no such path, we can simply return false. And we're going to solve this using iterative BFS. So looking at the constraint, it basically says that the number of nodes in the tree is in the range 0 to 500. So since there can be zero nodes, we are going to check if our root is null. If our root is null, we don't have anything in the tree. So then how can it be equal to something? So that's why we return false. Now, since we are going to use iterative BFS here, we need two values in the queue. First is the node, and the second is the current sum up until that node. So that's why we have created this pair class. And so the way we've done here it is that we've used a queue which stores like an object of pair type. So what it does is we have firstly initialized the queue with we have added the root to the queue along with root dot value, because up until the root the value the current sum is root dot val 0 plus root dot val, right? So then after that, we'll iterate up until the queue is empty. And if we come out of the loop, we are returning false. Why false? Because we are in the while loop, we are checking if we got any leaf which is equal to the target value. Now, if we came out of the loop, it means all the elements were processed and we couldn't get our target sum. So that is why we're returning false. Now in here, in our loop, we are going to check if we get any leaf with the target sum. So that check is done here. What do we check? If it is a leaf and the sum is equal to the target sum. The current value of the node is equal to the target sum. So in that case, we are returning true, else we are simply enqueuing and dequeuing. How do we enqueue and dequeue? So the parent sum is current dot sum and left node value will be current dot node dot left dot value. Same here. So that is how we have done here. So yeah, that was about the code. Coming to the time and space complexity, our time complexity is big O of n. Let's say there are n number of nodes in the tree. So every node is processed once. So that's why. And then we have this space complexity. Since we have a queue and we are, let's say W is the width of the maximum width of the binary tree. So at max, we can have big O of in space complexity. So yeah, that is it from my end. Thanks for watching. Bye.